Today we're going to be studying alkenes and alkynes. But to do that, we really have to understand alkenes because alkanes, all the stuff that we learn about alkanes can be applied to alkenes. So, first of all, let's look at all the different places that we could start from to number the longest possible chain in this molecule. All of those will work, and all of those would be both starting points and ending points. So any particular starting point could wind up being an ending point. Let's look at that and get rid of the marks for a moment. And now we can see, first of all, how to get started. Let's assume, first of all, we start here. We could call this carbon 1, and then we could go from carbon 1 to 2 to 3 to 4 to 5. That would be 5. So let's try starting from here. 1, 2, 3, 4, 5. Wow, they're both 5. Let's start from here again and go to a different place. And let's first of all get rid of those marks. And as we continue, I'm going to use a different color. And we first of all tried 2 different ways of going from this, and both of them gave us 5. So now let's try another way. 1, 2, 3, 4, 5. Oh my goodness. That's also 5. Now let's remove those marks, and we'll start again from here. And there's one other way that we could go. Actually, there's 2. So let's do them both, and let's do them in green again. That's a good contrast. 1, 2, 3, 4. Oh, that's shorter, isn't it? And there's one more way we can, and that is to go back this way. 1, 2, 3. So let's just do it the easy way and get rid of our marks here. And now let's just circle this guy. It's the easiest one to do. There we go. Got it right. And we'll call that our longest chain. And so this would be either N, by the way, could be number 1 carbon, because this substituent, let's change the color on that. This substituent right here is the same distance from the right end as this guy is from the left end. So we could make this either way we want. And let's number the carbons. 1, 2, 3, 4, 5. Do it from the easiest end. And now we can go ahead and name this thing. I'm going to use black for the root name. And this guy is, as we've numbered the carbons, this is a 5-carbon chain as the longest chain. And because it's a 5-carbon chain, we can name this pentane. And we have actually three different methyl groups here. A 1-carbon chain is called a methyl, and when it's being used as a substituent. And let's go ahead and name this as, and we'll call these guys, we're going to name these guys with blue, and we'll call it 2, 3, 4. Now, because there's 3 of them, we say tri, and they're methyl groups. They're all methyl groups, so we're going to call them methyl. And, of course, I put that on the wrong line. Let's get that up here. And a second, let's get it up. And let's get this up here where it belongs. So, 2, 3, 4, trimethyl pentane. And that's the name of that guy. Now, the next one, letter B, is a little bit deceptive, we might say. It looks like this should be our longest chain, but it's not. Why? Because if you start at the left, you'll count 1, 2, 3, 4, 5, 6. That's a hexane. Well, let's try starting from all the different starting points that are possible. So we tried starting from that thing that looked like it ought to be the main chain. Let's try starting down here. Now, let's try numbering. 1, 2, 3, 4, 5, 6, 7. Ah, we have more this time. But we need to try one more route. And that's when we get into what would have been, let's see, 1, 2, 3, 4, 5. I'm counting from where the arrow is. 5 into the chain that I just identified. Well, that's got a branch that goes up. Let's go up that branch. And I'm just going to erase these guys. And we're going to go right up the branch instead of to the right. And I'm going to start from the arrow again. 1, 2, 3, 4, 5, 6, 7, 8. Aha! That gave us one more. So what we've just done is we have identified the longest chain as being something that you might not have suspected. So let's go ahead and number this guy, and we'll also circle the longest chain. So here we go. 1, 3, and up and around. Boy, this guy just goes all over the place, doesn't he? And down and over and around. And there we go. We circled the longest chain. And we have 8. So that's 1, 2, 3, 4, 5, 6, 7. Oops. 1, 2, 3, 4, 5. Oh, I missed one. 5, 6, 7, and 8. Okay, let's do the alkenes now. With the alkenes, we're talking about substances that have double bonds in them, that are carbon compounds. Now, I'm just going to read this to you. End of longest chain, closest to double bond, is carbon 1, regardless of where any substituents are. So, if we look at this molecule that's down below where the writing was, or is, you're going to see right here is our double bond. That double bond is responsible for the ending of this particular type of compound. Now, all the rules that you used with alkenes are going to be good for what we do with alkenes. So, let's go ahead and say we started on the left side because this double bond that you see is closest to the left side. We go in 1, 2 carbons, and that's the first carbon that touches that double bond. If we go from the right, we have to go 1, 2, 3, 4, and then we have a touch on that double bond. So what we want to do is get the side that has that closest to it, and that's what we just did. So we've got the number 1 carbon identified. There's 3, 4, 5, and 6. And so now, what is this second one all about? Going from carbon 1, the first carbon that touches the double bond is number 1 on the base of the name. What does that mean? That means that carbon 2 right here is on the front end of the name, and 6 carbons in the chain, so that's a hex for 6. We would normally write it hexane, but this isn't going to fly with this guy because this is now hexene. So the ene ending is what we have every time that we get a double bond involved in the act here. So let's go ahead, and now I'm going to play with this guy a little bit. Let's get this thing out of the way. Group these together and move it up here. We started out with a 2-hexene. Let's add something to it. You might think that because I put that carbon there on number 5, that I have now a choice between the left end and the right end to call number 1. Well, I don't. Okay, this would be a methyl on group number 5, So as it's written right now, this would be 5-methyl. Let's circle this. That's on carbon number 5 as the thing exists right now. And this is methyl, which is a 1-carbon substituent, 2-hexene. And that would be how we would name this. Now, let's play with this a little more. I'm going to change this more radically than I did to begin with. 1, 2, 3, 4 carbons. And let's put a methyl right here. Now, let's see what we have. You would think that we could name it from the right or the left, but again, remember we cannot. The double bond is here. It's still on carbon number 2. The only thing that we did now is we made the chain longer, so this is no longer part of the main chain. The guy just erased. Carbon number 6 is now something different. Now I'm going to circle the new main chain. There we go. And you'll notice that I could have, if I had wanted, down in here, in this area, I could have gone down instead of to the right, and I would still have the same length chain. And now let's count out the carbons. We still have 1 to 5 will stay the same, and now we have 6, 7, 8, oops, 6, 7, oh, the 7 was there. Here's 8, and here's 9. If I got that right, let's count it. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, this is now a nonane. And that nonane has a number 2 in front of it because that's where that double bond is. And let's name the substituents. Now we have 2 substituents. The guy out here that used to be carbon 6, and the guy down here that I put on the what looked like a propyl substituent that turned out to be part of the main chain. So now I have carbons or methyls on carbon number 5 right here, 6, 7, 8. This is carbon 8 here. So we have 5. Let's do this in a different color. 5, 8, 5, 8, di for 2, methyl, 2, nonane. Okay, so there's our new name, and you can see how things have changed. I'm going to do one more little fun play on this guy. Let's get rid of all of these guys. And let's start from where we were in the first place. Get rid of our longest chain thing here. And now let's do a little fun ditty out here. I'm going to make this guy longer on this end. Let's see, I've got 3 on the left and 1, 2, 3, 4 on the right. So let's do a couple more. All right, now what is the numbering? And let's get rid of these other names. You can pick them up by backing your video up if you want to pick up what we had here before. But for right now, let's have a clean slate. This is the guy that determines who's carbon 1. If I go in from the right side, I have 1, 2, 3, 4. 4 carbons, and I get to that double bond. On the left side, 1, 2, 3, 4, 5. So, no brainer. We're going to have our number 1 carbon. Wow, let's see if I can fix that. Okay, we're going to have our number 1 carbon here on the right side. So, let's go ahead and number them. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now we have a nonane again. And that nonane has a 4 in front of it because the number 4 carbon sitting right here is the first one that touches as we go in from the right-hand side. So we're going to call this 4 nonane. And now we can put substituents anywhere we want, and everything will be determined so far as the numbering of the carbons by what we've done first. So let's go ahead and look here, and let's put a propyl in here. Oops. Yeah, again, a propyl. And let's put an ethyl here, and an ethyl here. And let's name this guy. We've got ethyl and propyl, so ethyl comes first because we always name the substituents alphabetically. And let's see what we get. I'm going to bring this thing down a little bit so we can see it more easily. And now we've got an ethyl group, actually 2 ethyl groups on number 6. And so let's go ahead and circle those. Here's our ethyl groups. And they're both on 6, so we say 6, 6, di for 2, and ethyl. 6, 6 diethyl. And then on number 5, I've got me another kind of a group, and we call this guy is a propyl group, and he's on 5, so we say 5 propyl. And let's change the color on this guy and make him red. Alright, so now we have 5 propyl, 4 nonane. So 6, 6 diethyl, 5 propyl, nonane. Or nonene. Oops, nonene. Ooh, goodness sakes. Nonene. E-N-E. Because we have the double bond. If I made that mistake earlier, be rest assured that everything that I did on this page is an ene. Just in case I did that error earlier, I can't see what I did right now. All right, let's go on. The next guy that we have to deal with is the ines, and they all end in Y-N-E-S instead of A-N-E, and the same rules as the double bonds. So our number 1 carbon for this guy is over here, because I have to go in 2 to get to the triple bond. And now I just count the length of the chain in total. So I got 3, 4, 5, 6, 7, 8. Wow, we have an octene here. So if we have an octene, O-C-T-E, oh, not ene, this is an ine now. Let's get this right. Octyne, O-C-T-Y-N-E. The octyne has a 2 out front because that's where that triple bond is. And so just like the enes, the triple bond will determine which end is going to be number 1. So even if we do this, let's put a substituent out here. Let's call this, let's do this one as a double bond, which is an ethyl, or a double carbon, which is an ethyl, and the ethyl is on 6. So let's go ahead and circle that in red, and we'll have 6 ethyl, 2 octene. Oops, let's get this guy all together. Grouping. Now we can put him over next to it, so it looks like it's all the same thing. 6 ethyl, 2 octyne. So I hope this helps you with the enes and the ines.